So today let's talk about the chain rule. Before this section, you should have learned some basic rules of differentiation, such as the addition rule and the subtraction rule. You should also have learned the product rule and the quotient rule, which are a bit more complex. So by this point, you should be familiar with these rules and can easily differentiate the functions presented in this slide. If you feel some difficulties, I recommend you to go back to the previous chapters, fully understand these rules before you watch the remainder of this video. So let's now take a look at a new set of functions. These functions, so for example, for the first function, you want to say that you may say that it can be differentiating these functions can be as easy as differentiating the ones in the previous slide. Well, for example, for f of x equals to e raised to the power of 3x, you may say that f prime of x, the derivative, its derivative is still e raised to the power of 3x, since you have learned that the derivative of e raised to the power of x is the function itself. So let's take a look at this thought. Okay, so it's here. So I have graphed f of x and f prime of x, and you can see that these two functions clearly don't overlap. But when you take a closer look at these two functions, you see that f prime of x has a y-intercept of 0, 3, and f of x has a y-intercept of 0, 1. And you may say that, well, maybe f prime of x equals to 3f of x. So let's check. So we can see that 3f of x is just equals to f prime of x for all real x. You notice that after you differentiate e raised to the power of 3x, you still need to multiply it by 3, which is the derivative of 3x. This is actually so for a composite function d f of g of x, you might realize that you also need to differentiate g prime of x, and this is true according to the chain rule. So given dy over du and du over dx, how do you determine dy over dx? Well, you notice that by multiplying these two expressions, you can directly get dy over dx, since du in the two expressions cancel out. And we have actually found the chain rule, and we are just lacking a few conditions. If y equals to f of u is a differentiable function of u, and u equals to g of x is a differentiable function of x, then the derivative of f of g of x is dy over is equals to dy over du times du over dx. If we use Newton's notation, we can see that dy over du equals to f prime of u, and which is equals to f prime of g of x, and du over dx is g prime of x. So the derivative of f of g of x can also be written as f prime of g of x times g prime of x. Now let's come back to these functions. These functions are composites, functions like f of g of x, and you need to and you need to find what is f of x, what is g of x, such that f of g of x equals to the function you are given. So think about how to decompose these functions. For the first one, you can write f of x equals to e raised to the power of x, g of x equals to 3x. So f of g of x is e raised to the power of 3x. Similarly, for the second one, when you decompose the function, f of x equals to sine of x, and g of x equals to x squared minus 2x plus 1. The third function is a little so think about how to decompose these three functions. I'm not going to show you a step by step how to differentiate them, but I'll put the answer to these questions after this video, and you can check after you try them. And I believe that's all for today, and thank you all for listening. If you have any questions, please just tell us. Thank you. Just tell us. Thank you.